Hello and welcome back to Jesse's Vintage Garage. In this video we're going to be working on the valve train, getting that installed, the push rods and all that stuff. But we come across something here that we got to probably do in this video. But my father, he turned around and bought Panheads, replica heads, and in the description on them heads it talks about the stock lift height for the valves, and it's 4.25, right?
Yeah. Maximum cam
lift. Okay, that's the best way to say it.
Valve lift.
The proper way. Anyway, we got to have that. We have to have more than that when we're running this BH cam that we have in this.
Yeah, because this is minimum 470.
Yeah, 470. So what I'm getting at here is we feel like, looking back in the footage when we were building these heads, one of the very first videos, when I got these heads, they were ready for high lift and everything in the description, and I got them all fixed up and stuff. But then looking at the footage, the top retainers do not look deep dished enough to be flat. Yeah, to be for high lift. So I don't think it has high lift stuff. So what I'm getting at is we're going to be taking these heads off again, or off here now, and opening them up, switching out to high lift parts, because I can't just assume that they're right and then go and start this thing up and something happens, seizes up, or whatever. I don't want to risk any of that stuff. So we're going to be going over showing all that, and then we'll work on timing, I think, in that process too, because it's part of this also. So let's go ahead and get started with first off taking off the heads, I guess. Well, we're going to take the heads off here in a minute, but anyways, the stock height on the Panhead is, we were just saying, it was 0.425, right?
Yeah, 425.
So the J grind, like I was saying a little bit ago, is the J grind here.
Valve lift, 425.
Right, and then I came across a paper that mentioned that if you don't run a stock cam with 0.425 lift, we're gonna have problems. You got to do head work. Well, that's what made us all look into this stuff. And then even the FLH cam, or the Victory cam, even has it was within the spec.
Yeah, it's all 425.
Right. So we're wanting to run, like, we have the BH in there, which is down here.
BH 470.
470.
Pan.
So then, this paperwork doesn't really say that if you're going to be running this, you need to do any sort of work. So that's maybe where I came across, thinking we're going to be fine.
On their website, they show some descriptions on this side, and all of those descriptions show that all these cams are bolt-ins, except it doesn't say Panhead. It all says shovel head. And then they tell you that 80 and 81 shovel heads require some valve rework, but it does not mention nothing about Panheads.
Yeah, and then when I bought those heads, those nice heads for the 56, the person that sold them to me said that they were ready to go for whatever you wanted to run for a cam. They had the high lift stuff in it. And then me not realizing that they didn't look like it, we would just kept going on. But now that we look back at the first video there, it can clearly see that they're not high lift. So now we got the parts for the high lift stuff. It's just that
if nothing else, we're going to check it.
Yeah, well, we're gonna now take a head off and then see what it looks like. So yeah, so looking at this overall full list of these different
old list.
This old list, yeah, like you said, this is this whole list of all the different Andrews cams that were available from the beginning, pretty much. And then you get down here a ways, this DH or DM and 9, 10, and Z and 14. They don't even have Panhead listed, so that must be
they're not
pure shovel head only, right?
Yeah, because they stop at 550. I don't know if you can get that much out of a Panhead. We're going to find out.
Yeah, I mean, if I remember right, the rockers kind of move around a ways. So
the ratio's different.
Oh, okay. Yeah, you'd have to
shovel. See,
how the actual rockers themselves would have to be redesigned or something.
The rocker arm ratio is different than a shovel head rocker.
Yeah, and the only reason why we even he even got panheads, those panheads, those stock ones that made us even question it was the fact that, yeah, it's project, we're going to be using those in coming up in the future, so that's why that's even relevant. But that's going to be its own video series, so we're not really going to show them heads because there's no difference in the heads that are on the bike that we're working on. So, yeah. Here are the high lift Andrews collars and spring set. It was together both the springs and the collars. It's part number 271100. They're for shovel heads and pinheads. They take the same stuff. So, anyways, you can see the difference here in these springs. This is the inner spring. This is the outer spring. And here's the stock ones. Stock outer spring, stock inner spring. So we're gaining squish here by having less coils. Now we have another panhead head sitting here. We've been messing around trying to figure out our dimensions that we need to do here. And on this head particularly, I'm going to be running in a different motor sometime down the road. We'll probably see that project down the road. But this set of valve guides that are in here, we did the measurements. We have to come up with about 490 in travel here, right? Is that what you're saying?
This has 490 travel. So, but we need 530 or 520 to have the cam that you have in your
in the 56, yeah.
In the 56. Or the cam that you're gonna, like that AB, if you run the AB cam, see the AB is the same 470, and it says the travel on a pan is 490. So, and we got 490. That's not enough for over travel, and you need more. And
so we need to reduce on this particular head, we're gonna have to reduce this down.
Yeah, by about 30,000.
And then if we're gonna mess with this head, we'll probably do this in a different video down the road when we mess with this one. But we'd also want to maybe install guide seals in here, or intake seals on this.
Yeah,
that'd be nice too. And we'll probably end up having to do that down the road. But we're not for sure what the 56 guides look like for depth. So we're going to have to do the measurement there on that one. We can pull them heads off. But just tinkering with this one, we already know that there's a problem here, of course. And anyway, I mean, because if you're going to run a J grind, like I was saying, I think I was saying before, that's fine. But not very many people probably run J grind because it's pretty much a stock cam.
yeah.
Duration and maybe a little bit different, but
it has the 425 lift, and that just fits right in there.
Yeah, that'd be equivalent to the Victory cam that the FLH would have had, 55, 56, and so on. But I wanted to run the AB, which would have been BH, I mean, which would be more aggressive than the Victory cam.
Yeah, it's got a lot more 256 duration instead of 242, and instead of 425 lift, it'll have 470.
Yeah, but to get that, we have to do alteration to the... So when they say in the instructions that you need to do head work, well, this is the head work you need to do. It ain't just putting the springs and keepers and retainers in. It's actually messing with the valve guides. So we're going to try to go over all that here coming up. All right, we have a stock panhead retainer in there.
A retainer. And I left the lower one in it, so we're going to use this for measuring purposes. All I did is put the keepers in and push this in there. Now we're going to push this all the way down and take all the play out, and that's maximum travel. You got to think about maximum travel, and we're not hitting, the valve isn't coming out of it. So now what we got to do is we got to hold there. We're going to come down here like that, and we're going to bring that up and touch. Okay? Right there.
It's sitting pretty flush, I guess, yeah. Okay.
Then we are going to look at this. We got one, 103. So we got 1 inch and 3 thousandths is what our maximum from retainer to the guide clearance. That's maximum movement. So now the next step is we would take the keepers back out, take this off, and we will put an inner spring only in. Got it?
Yeah. I'm just going to compress it all the way down.
I'm going to compress it enough to where I can put the keepers in so it can set in relaxed. I don't know what the upper is.
Oh, that's what you're figuring out with this.
Yes.
It's going to hold it up. No. Okay. I was wondering if you're going to show travel with the spring, what the spring was allowing to travel.
Well, I could do that, but I don't think it's necessary.
Because if it smashes down and the upper collar is actually the upper collar is actually hitting the valve guide.
We have to have two measurements.
Yeah.
We have to have the measurement for compression, and we got to have the relaxed state. Okay, and so this would be, now you got to consider that this is the stock, but this is what this head would deliver without putting any of this new stuff in. Okay, so now we would write down 1.003. Okay, now the next thing we're going to do is we got to make this measurement again. So we're going to come down here and we're going to come right to there. And now we have 1.484. So we got 480. So you got to remember we got 103. So we got to take 3 more off of this. And we got 4. So this 81. So we got 481 is what this travel is.
Okay. And we need 490.
Well, yeah. Well, that gives you 20 thousandths free play.
With nothing in between. Nothing,
Yeah,
no extra.
no extra travel. And that's to the valve guide. We're not talking spring, we're not talking coil bind here at all. That's another, this stuff is going to take care of the coil bind. What we got here to worry about is what we got from the underside of this retainer to the valve guide itself. We only have 0.481 travel. That's our total travel. Now, if you just idled around, you could probably run that 470 cam, but you're only going to have, 11 thousandths over travel. That's not enough.
Oh, you're going to have a problem.
We're going to have trouble. See, so that valve guide needs to be trimmed down. We need to have more room. And
Okay.
so
we need to be taken off about how much for this head?
for this head, we only got 11, and they say you'd want, actually somewhere, they talk about having 50 to 60 thousandths over travel. So we would have to take out, let's say, 40 thousandths to bring us up to 50.
I'm about to get the cutter out.
And we'd have to cut that down. We'd have to cut this down 40 thousandths. And 40 thousandths isn't a whole lot when you look at it. That's 40 thousandths. That's doesn't look like a lot, but when you say 40 thousandths, wow, that sounds like a lot. But when you look at that little crack there, that's not really cutting that guide down. It's not like you're thinking, geez, we're going to cut half of that guide off there. No, it's not. It's barely touching it. It's just taking some of it to give us extra travel for misshift, let's say, or over revving, missing a gear, things like that happen in real life. So, and that's what that extra travel is all about. It's for
insurance policy.
Yes, it's for mistakes that happen. Because if it comes in contact with that guide while it's running, you either bend a push rod or you throw your cam out of time. Those are the two options. Or you mess up a valve guide. And after that, your valve's running up and down and it's scoring on the valve because you just mashed into it.
Yeah.
So, you know, things like that is what it's all about.
Here we are. We got the front head off, and well, these springs look different than the other springs we were just showing you, but they're real similar to the Andrews ones. We're gonna find out, but we can clearly see, like I was saying, that the upper collar is not deep dish like this one. So that would be a problem.
That might be all we need to do.
But we gotta see what them guides look like in there. So we're gonna take we gotta take this off, and then we're gonna pop these apart. All right, so we did all of our measurements here with this head, and we have the smaller spring in there now, and then just holding it up here.
Just like this.
This is measuring different than the other head, so that's a good thing we ran through the other one. Now we're doing this one for sure. It's just what we need to do.
Now we got 1, 5, 14, which is our first measurement was 1,051. Our second measurement is fully extended at 1,514. You subtract those two, and our total amount of movement from crush, or from 0 to out, or 0 to 0 basically, 463. Our cam is 470. So we gotta reduce the height of the guide.
Yeah, so we need to gain 5 something.
We gotta gain.
Yeah, we need to change this number from 0.463 to 0.500 for sure.
Yeah, well, just a minute. I'll tell you exactly what we gotta have. We need. Okay. We need 52 on top of 470.
Okay.
So
minus 470.
Just a minute. We got.
So what did you end up with?
There's 7 thousandths.
Yeah, 7 thousandths between 463 to 470. Yep.
470. Then
that gives us what we need for sure. But
that's what the cam is. So then we need at least a minimum of 50 thousandths
for
over travel.
Yeah, when it's revving up and stuff.
So that brings it up to 0.57. So that means 57 thousandths has to be taken off this guide. Now we'll have to check all 4 because that's what'll have to happen.
And we'll do that as we start grinding these down or cutting them down. So
well, we're gonna have to get the tool out to grind the valve down.
Yeah, so let's go ahead and
move
on.
Down.
Let's get ready to move on to that, I guess. We're trying the new retainers here just to see what that measured out to, and actually made it like kind of worse in a way.
Well, we don't know that yet until we put the spring in if it's actually worse.
Okay, yeah, but instead of the 1.051, we got 1.088.
That's because this is taller because it's dished. It's taller out, so that's the only way that would stay the same is it would have to be flat.
You can't compare the two. We're gonna have our own set of numbers. I understand that, so I'm just trying to explain that. But yeah, now we're gonna do the same measurement with that spring. That was the original spring that were in here, not the Andrews spring, but it's not.
It's just an inner spring. All I want this for is so that it's got. If I could put a weaker spring in there, I would. I just want something to hold the valve fully closed.
All right.
530.
We got
we're looking for.
we got the Andrews spring in here, and we have the Andrews high lift retainer in there, and these are our numbers we got. We got 1.088. That was before it was.
That was totally collapsed.
Okay, and then here it is extended out right now, 1.619. We have a difference of 0.531. And
so you take that, we got our cam at 470. So that's going to give us 470 lift.
okay, so for the 470 lift, and then taking them from that, we get 0.061. So
We got enough. We don't have to do nothing. All we have to do is put the new springs in this color on, and we got 61 thousandths. We got more than enough.
huh, wow, okay.
So if we can get this to work on those, we might not have to cut down the valve guide at all.
Okay, that's the reason why we did this. And then the other thing is, if that, then we can still get out that tool and put in the seal. Then I guess groove for the seal or whatever. So, and even adding the seal, and you add in your difference for the seal, we're still gonna be okay.
No, we'll have to cut it down the thickness of the seal if you're going to put seals on it. There's a height of what the seal is that sits
Right.
on top of the guide, and that could be 30 or 40 thousandths. So you're going to have to cut down quite a bit if you're going to put a seal on it.
Yeah, I mean, they didn't originally do that. And
No.
it's not necessary.
We
but
weren't going to run it with seals because it didn't have them. So we can try it without. If we have smoking problem, well, the worst problem we'll have is we'll have to take the heads off sometime and
do this all again
and deal with it.
And put seals in that. I
Put
guess.
seals in it, yes.
But all right, well, I think we're gonna be okay with just switching out the springs and collars then, I guess. So it was nice to figure that
Or at
out.
least this one. That's how we'll do these one at a time.
And I think the intake is the culprit more than the exhaust, anyways. Because I don't know. I'm just thinking that maybe there's probably more movement here on the exhaust side than there is intake because of the fact it gets warmer over here. But maybe that's a bad assumption.
Well, it just depends upon the guide, how far into the head the guide got pushed.
Yeah, we don't want to mess. The other thing was we could take the guides out if this wouldn't have worked and put new ones in. But the guides are good in these old heads, and you don't want to really disturb that if you don't have to. That's why cutting would be the option to go and trimming it instead of just taking a guide out and putting a different guide in. But you don't want to mess with that any more than you have to. Then your guides are loose all the time.
Right.
Well, here's our result on the exhaust guide for the front head. We had a total of 1.111, and then when it was totally extended, it was 1.600. The difference of 0.489, we need 470, we're down to 19. So we're going to have to do some modifications to the guide on the exhaust side of the front head. So we'll work on that, but we got to get the other head off the motor over here, and
We're going to have to test
and
that one too.
and test and do all the checks on that one too now. So we'll get this off of here, go over that, and then we'll start the grinding process on the guides.
Take about 10 thousandths out of each one.
All right, with the rear head removed, we went through the measurement procedure, just like we did in the front one, but we just kind of like jumped through it. You didn't need to watch it all over again. But this is what we ended up with. The exhaust on the rear head was 1.108 on total
On squeeze.
on squeeze. Yeah, right. And then, thanks. I keep forgetting what that is.
And
Okay.
then the other one's expanded all
Okay.
the way out.
Okay, so all the way out, 1.628. It came up to a difference of 0.520 minus our 470 lift on our cam.
Gives us 050.
Okay, so that's what we got there.
50,000.
Which we could probably run that if we didn't want to have an insurance policy for over revving and neutral
50,
drops and
it
stuff.
says 50 to 60, so it would probably work.
Okay, so then on to the intake then. Intake on the rear head, 1.620. So each one of these valve guides are different now. So 1.097, and then that comes to a difference of 0.523. Our 470 comes out to 0.053 difference, and which would work too.
That's
But
3 thousandths more than the other one, but that's, yeah.
yeah, so we're gonna get our tool out now, and we're gonna shave a little bit off just to get at least 0.06 probably, right?
6.
So
We'll try to go for the 6.
we're going to do that to this head and the front
because
head.
we have to do it on the front one. The front one is, we got one that is real tight.
Yeah.
So since we have to do that, we could have probably got by with this one.
But yeah.
We'll make them all the same.
So just popping in the nice retainers and the springs wanting to cut it. Yeah, totally. That's what we're finding out here. So, and you can buy these from Andrews as a full kit, or you can buy them individually. I'm not sure the part number for the full kit is offhand, but the part number for just the upper collars is 271100, and the spring set 272110. So, yeah. Anyway, that's that for you, and let's just start removing some material on these guides. Well, since we got the measurements all figured out on the rear head, we're going to go on to just doing the front head again because we started there. I got the valve seals over here. They're made by Kibblewhite, and that was a 71035-4 for the 4-pack. You can get them in all the way up to 8, I think. Maybe more. I don't know why you'd want more. Well, you could if you're going to be doing bulk sale or whatever you want to do. But then I got the Kibblewhite installation tool here. This is for panheads and shovel heads. And that is 20-20833 by Kibblewhite. And it covers panheads and shovel heads. Okay, that's that for that. We got a different ring compressor or spring compressor here for the valve springs because we're having a heck of a time with the other one here. And the other thing is this fancy tool here that it takes the we talked about in the beginning. It's a tool that takes the valve guide.
It cuts them down and has them sized. It sizes them for the.
It reduces the height so you can get them deeper, so you can get your valve height, and then it has an extra part on it that does the valve seal.
See, and as you turn it, if you look there, as you turn it, it will cut. It does two things. It cuts down the outside to be the proper size so that this fits just right. The other thing it does, if you look real close, it has another auxiliary cutter right there. And that's reduced inside of this round piece, which is the size of the hole here. So that takes the top down. So it sizes the side and cuts the top down. So you can't just keep cutting. You got to go to a certain point.
Right, and this tool, Silver Seal Products, and it's really good. This is actually built to grind on cast iron valve guides, and luckily we're working on brass, so it should be pretty much a walk in the park for this tool compared to running like grinding on iron.
Well, so it's carbide.
Right.
These are carbide tipped, so you can see that that's a carbide tip welded to this or brazed on, or however they do it. But anyway, these are carbide cutters that are on there. So cast iron, brass, it'll cut it. It'll cut pretty easy. It should cut it real easy. So all we got to do is we got to cut this down.
Yeah.
I measured this seal, and according to the outer thickness, because we got to worry about how much space we move. So we don't want to go to there. We want to have 60 thousandths in here like this. Whatever 60 thousandths is. Overall, we want at least 60 thousandths.
We want a gap.
We want the gap. We don't want to go here and have it just make it.
Touch.
So we want to have 60 thousandths. And so I measured the edge, this edge to the inside edge to where it goes down onto there. And I come up with 109 thousandths. So basically 110 thousandths. And so that means we got to go down whatever our dimensions were that we needed, plus 109 more. So we're going to have to figure out what this whole amount was that needs to go down first.
So we got to do some more math quick.
Yeah, we got to do just a little bit more math, and then we will start this project.
Alright, so here's the tool here. We just have it sitting there. We haven't started grinding anything yet though, but our measurements come out that we were good without, if we weren't going to run seals, we would have been good just putting it together on this intake one. It was the exhaust that was messed up or too long, and you can kind of see that it looks different than this
We have,
this valve guide here.
yeah, when we put this collar in here, from this edge to here, we have 400 thousandths.
The smallest edge here, you can't see it with your
Top,
yeah,
furthest up.
Yep.
Okay, so now when I do that to this one, well, got to do this right, I guess. We are 412 thousandths.
412 thousandths.
So we're about 12 thousandths long on this side. Longer.
Yeah. Well, we might. I think we're gonna run seals on both intake and exhaust, just because I don't want to smoke. It's extra work, but I think we're gonna be better off in the long run, right?
Yeah. Well, new heads come with the new heads I was thinking about buying for mine. Have intake and exhaust seals on them. These same seals. So it's like, well, why not? Then we don't have to worry about gas pressure coming in here, oil being pulled down in here, and so now we have to decide how we're going to use this tool. In a drill press, or are we going to use it on a hand drill and just drill it down?
Well, this has a guide built into it to keep it straight and true inside the valve guide.
Yep.
So there's a 90% chance that that'd be fine. But then again, you know, there's a little bit of free play there. So I don't know if the drill press is going to make a big difference or not. So
it'll cut right away.
Yeah. Well, unless you have some sort of tool to do it by hand, but...
Oh, no. It's going to take some off right away.
Well, I wasn't going to record this at first, but... because I was kind of nervous about it, but it's actually turned out pretty good, so now we'll watch, I guess. Yeah, wow. Yeah. I don't know if our measurement, yeah, we're going to be doing this for a while, going off and on measuring and stuff.
Well, we had 140.
Okay.
We had 140, and we need to be 109 or 110 thousandths lower than that. So that's what it amounts to. And so
yeah, let's see what we got.
okay, so what I need to do here, we need to be okay, so what I need to measure this and then add 109, 110 to it. And that'll tell us what we would be once this
What
is
the height of this added in.
Yeah, but I have a funny feeling we're already down enough.
Yeah, it didn't really take much.
No, it ain't going to take much. Three 350, 355. So 109. Well, there's 400. We're only 45 thousandths. We might not be enough yet.
think we got enough material off here. We're at, what was it, 110?
Yeah. Yep.
110 more than what we needed. So we gotta make this one kind of look like that one now. And then if you take the inside measurement of this with the mic,
we got a
the
little
I mean the digital dial caliper there, we got a little bit of a gap between the two.
So we should be good. Because we got to go by what the height is here too. And we won't know that until we drive this on to find out what we actually got.
Yeah, and hopefully we're there. Because these are a one-time put on and they're garbage after you take them off.
A half inch here.
Okay. And we need this side to look like that.
Yeah. And what we have here, we have a gap. Quite a bit of a gap. See that?
Kinda.
Okay,
Yeah.
there it is. We got quite a ways to go.
So we did some remeasuring just to make sure everything after we got done turning those guides down a little bit, and we got some situation here with this. Can you explain it pretty good?
Yeah, well, what we find out when we have these blue retainers, these high lift retainers on both sides, the cover don't fit.
And that's a problem.
Because see what happens is it comes down and it won't if you look at the screws, they're off. It's off a half a hole.
Yeah.
So
and if they have
when you put them both in here, it don't even go down. I could show you a picture. It comes down to about here and it stops.
And we don't have the room for a spacer or anything to make this work. No. We don't have. I mean, if we were running like a chopper with a stretched frame and stuff, we could probably lift the cover up a little bit with like some sort of spacer, but it's not an option.
So these lifter being out further brings this out into if you look at it, if you get it just right, and you look over here, see how it sticks out past, it sticks out past, and you're into the gasket surface.
And that's right into the wall of the pan.
So we can't have it. It just won't work. So
off camera, we did a bunch of
spring compressings, and we found that the stock springs give us this distance, okay, and we need to have this number, 60 thousandths. With this number, this is the stock springs. That would be this spring and one of these springs in here, the ones that came with the motor.
Yeah, and
these are
the ones that
these are new. And so when I compress these between the lower retainer and the upper stock retainer, when I compress these in there, I got 1.060. It compresses down more. If I use the stock springs, it compressed down to 1.089. And then if I measure this the same way, I come up with, see, I had to put a spacer under here because you got to remember I measured between these two compressed. So I had to come down and put this in here like this. And I come up with this, which is that 1.590. And so when I take the compressed Andrews springs, the high lift springs, and I compress them clear down, I get 1.060. So if I subtract this 1.590 from, if I take 1.60 from 1.590, I get 530. And then if I subtract 470, which is our lift, I get 60 thousandths. So we are just there. If we use the Andrews springs and the original retainers, because we got to have the covers got to go on and it's got to work. We don't want to hear clang, clang, clang every time the motor comes around, because the covers, these retainers are coming up and ticking on the cover every time the valve goes up and down.
Yeah, and then we don't want to switch out the cams. That'd be the other thing.
That'd be the next thing. If we can't get there, we'd have to replace the cam.
And we don't want to keep tearing it apart.
No,
so, yeah.
No, this will work.
Okay.
We can make this work. So now we're at the point. Now now we know what we're going to do. We're going to put the seals on here on intake and exhaust. We're going to not run the blue retainers, the high lift retainers, and we're only going to use their high lift springs, which has less coils. As you can see, it's easier to see this way. As you can see, there's more coils. And so what happens is this one can squeeze down tighter than this one does. You get coil bind. You get coil bind at 1089, and this one coil binds at 1060. So this is the better one. For us, this is going to work.
So if anyone else runs into this situation, that's something to look at. You really got to do a lot of measurements and mathematics and stuff here.
Yeah.
Didn't really want to bore you with all this kind of like crazy mathematics and stuff, but this is vital. This is vital stuff again that we don't want to like hide or not show like some people like to do.
Once we put this together, we want to be able to roll it over and have confidence that we got 60 thousandths of over travel from coil bind and from the underside of. I don't have one right now. From the underside of the black. Oh, there it is. From the underside of this to the guide or to the seal, we want to have 60 thousandths.
Yeah, we don't want that thing banging.
And actually, we're going to have 77 or 70 thousandths between this and the seal. So we're going to be setting. We're going to be setting good. So.
Right. Yeah, that last segment was pretty intense with all the different numbers and everything, and hopefully it didn't like lead you the wrong direction. But you know, some people would probably just put this stuff together and just move on, and you wouldn't know the difference in what the actual deal is. And then when you go to do it, you're like, how the heck did this happen, or how'd they get that together? Why didn't they show that? Well, we're not them kind of people, so we're really trying hard to explain things to people, and I hope you appreciate this, because we feel like there's a lot of stuff out there that needs to be said. Just like a lot of the other videos that I put out for this 56 and the Evolution and the shovel head and whatever else we're working on. We just try to like really show details. It's not about us, it's about the product we're working on. So just keep that in mind. So I appreciate that. And yeah, we're going to keep going here. I just don't want to switch out this cam. If you remember when we were working on the motor, how much of a big deal that was putting the cam in and getting all that measurement right. I mean, I'm glad we came across this and we're dealing with this now before it would have been a catastrophe when we started this thing. And we didn't want that.
Whoever set up this head.
All right, so we were just chatting here a second, and before we get going here on this, but what would have really avoided all this in the very beginning is if, you know, typical head work, actual head work, where they would have had to like come in here and machine this down and make it to where it's set lower.
Yeah, see, there's what you don't see is there's a fiber gasket here. I'm not really sure if that's standard or not, but
this head has them on all four guides.
Yes.
And
but when you put this on, it sits up in the air a long ways. There's a lot of gap there.
So we could have reduced that gap. What they're doing though is they're making it to where the spring isn't pushing on the aluminum. They're making it to where it holds onto this.
And that's fine. They could have ground this ledge down, or they could have did several things.
But, that's what we could have done too. But
you're going to have to, because if you're going to need a tall lift cam, that's the only thing you can do. Somehow you got to increase this freeness, like what they're trying to do here. But we can't come up here because it hits the cover.
Yeah.
So the only other option is to go down.
Yeah, freeness is go that direction. And yeah, I mean, we cannot run a cam that's any more stout than the BH is.
Yeah.
So I mean, they make more stronger ones, but no, we're not going to be. We're going to be running this one, and got another motor coming up. It's going to be a Panhead too, and we're going to make sure I'm not going to be running a BH in that or anything better than stronger than that. So we'll see. So. Okay, we're pretty much finishing up on the front head though, but we're still working on this rear one here, but we moved on to getting a different set of stuff. Now, Kibble White makes a nice set for 48 to 65 Panheads. They call them a high lift spring set. And it comes with upper retainer, lower retainer, keepers, and springs. Those springs we've checked over with the Andrews one. We checked the upper keeper with Andrews stuff, and they're all different in their own way. And we'll probably go over that a little bit here. But on the Kibble White website, I got it pulled up here on my phone, and here's the kit right here. Racing Springs kit with 0.600 lift is exactly pretty much what we need, because that gives us our...
We only need 530.
Yeah, we only need 530.
That's more than adequate. Way more than that.
I mean, it's kind of spendy, but not really, because the Andrews was a little bit cheaper than this, but not much. And there's the part number for the kit.
And it's for Panheads.
And
48 to
yeah,
65.
it specifies Panhead. He doesn't say something stupid like Panhead shovelhead, then you find out it's not really for a shovelhead, and then you're or not really for a Panhead, and then you're all mad because because the dang thing doesn't fit a Panhead right. It's more for a shovelhead, and I just don't like it when they have multiple engines listed on that stuff, where they're both different in their own ways. But anyways, we got other Kibble White stuff here. We have the seal installer. We're going to put seals on the rear or the intake and exhaust. We bought special or extra seals because we're going to have to do some trial and error. We're probably going to damage some seals and stuff just to try to figure out, because we're going to take, we're going to maybe not show all of it in the video because it's going to be a long video if I showed everything. But we're going to take the head, put it on the engine, kind of rotate it, see where we're at, and see where we're gaining and losing on or whatever, and go from there. So just going to try to work our way through this here, make this video as kind of short as possible so it's more pleasurable to watch instead of watching an hour or two video. But anyway, that's what we got so far. Okay, so rear head, front head. We've been working on the front head here, and we'll get to the rear head, and we'll show all the stuff we've been doing coming up. But what I'm going to show you here is what we're coming across. And what I was talking about in the last segment, you can see that this retainer and this spring is kicking this out over the flange here. Now, if you look at the Kibble White stuff, it's not kicking it out over the flange. And what we did is we don't have nothing installed here, but we take the Kibble White retainer, which has a special recess here, and goes over top of that, and it actually drops down closer.
And it's got an opened area here for the seal.
So there's a seal right over there, yeah. And the seal can go down deeper.
The seal fits right inside of here, so we don't have to grind the seals down.
We don't have to grind valve guides down as much.
Right, and if you look at the other valve retainers, which is
over there, I think there's one. But anyway, we take while he's getting that, we take that Kibble White stuff, we put the valve in, we put the Kibble White springs on, and the upper retainer on the top there, and we already test fitted this, and the pan does go down. That's a very important thing to me. And the motor, because you got to have them on there.
It's right here.
And obviously, and then
so this one's flat. See, this one's recessed and deep, and this one sits flat out here. So once you cut these down, then you have to start cutting the seal. Well, you don't want to do that. So because this one sits on top, it doesn't go down far enough.
No,
it's not made for this tall of a lift.
It's gonna be hard to see though, but we did do this one already, and it's set up just right. We have the Kibble White lower retainer down there sitting. We have the valve seal in there. We have gap,
and you actually see guide below the seal.
Yeah, see in there very well. Yeah, there we go. And this is exactly how it needs to look on this side now. So we'll start installing this stuff, and we're gonna go put this on the engine and see how far we've come yet. So all the measurements we did in the very beginning of this video, it wasn't for nothing. We still needed to figure out the height this needed to be. So we could get this to go down as far as possible, so it wouldn't hit the top retainer when the springs were compressed. All right, with that being said, we figured out our measurement from what we were doing in the beginning. We're going with 4.470 as the height here. So then inside these, it's got a metal spot right there. You press these down on until it stops here, which still ends up going inside of here like I was showing, like we were showing.
Gives you plenty of room.
And then when you have this on here like this, and it sits inside there, and you press it down in, it still spins around and stuff, so we know it's not, you know, binding or nothing. So the other thing is, when you're working on the panheads and stuff, and you want to achieve like a maximum lift of 1.5 installed height, like it says here in the Kibble White instructions, they specify here, in order to achieve the 1.5 lift installed height, which is a lot more than what we're running, I feel, you'll need a spot face the surface under the or around the valve guide to a diameter greater than the base washer. The base washer they're talking about is the retainer, the lower retainer, and what he's going to show you.
And this, they're talking when you got your valve guide out, you can spot face this down so this retainer goes lower, and so everything goes lower, and that's what you'd have to do. And we don't want to do that, because
and the installed height would be this all the way to here.
Yes.
It would drop it in.
It would be from the bottom. It'd be from the inside lip of this to the underside lip of this. That's the installed height. Is there to there when it's done.
So now we
have a 1.4 right now. I already checked this. We're right between this. We're not quite 60, but we're about 155, 157, somewhere in there, of the ones I checked. So
1.457.
That's installed height. That's factory right here. So
installed height. What we got?
We got between, this is minimum, this is maximum. Well, that's what they're giving you a range. And I'm about you are about 156 or 157. Almost 1.6. So we could have been as much as 1.7 for far out.
So it's more than this.
It's closer to the minimum or the tightest.
Okay. Well, we're working on moving on to the rear head now. With the front one's ready to go on. So starting off, knowing stuff from the front head, we know that we need to take off the excess material in the gasket that's underneath the valve guide here. That's the factory thing that comes with the valve guides when they get installed. And anyways, so we got to remove a little bit of material here, otherwise that the lower retainer doesn't go down. We found that out with the last one. And then we got, this has not been touched yet with our special tool here that we showed already in the beginning of the video. So we're going to have to come down, and we need to have 0.470 on a height from the base of this right here, this edge, to the top of this. And it's going to give us our length. It's going to grind off the length, and it's going to give us an edge that looks like this right here. Then we can install our seals. Well, there'll be a specific order. You got to put the lower retainer on, then the seals, and then from there. We'll see all that coming up. That's where we're at. Yeah, what's that?
597.
Yeah, we gotta get down to 0.470. So
470 from 5, almost 6.
So it's going to be a lot. It's going to look like a lot too, because
we gotta cut a lot.
Because when the brass starts getting cut and stuff, it starts going everywhere, and it's nice and shiny, and it just looks like a big pile. So we'll see that here in a second.
528. We're still a ways to go.
I mean, we got to at least get our 470, so we can go a little bit farther, but it's kind of hard to judge just because there's
It's
like...
got to go a ways and check it. Oops. There it is. Right there. Close enough.
Yeah, 470?
470, 471.
Almost 471. Yeah, that's pretty close.
Let me check it again. Yeah, that's right at 470. That's close enough.
Yeah, now onto this one. Then we got to clean it really good. All right, we got the other valve guide turned down and it's looking good. We got the lower retainers on, ready to assemble this all up. And we're gonna go put this on the bike here once it's all assembled. And we're gonna do a trial run without the rocker box on, and we're gonna push rods in and stuff, and we're gonna see if we can verify that we have 60 thousandths
Over travel,
because that's what we need to achieve. And
at least 60,000.
and see, in some aspects, people that would be rebuilding this stuff may have to do the trial run 3 or 4 times with all the stuff. That's why we have the extra valve seals. And we ended up having to, when we were doing the trial run on the front head, we ended up going through some extra valve seals because we weren't quite there. We didn't want to like go crazy with video recording and showing that whole thing, but we're going to just kind of like walk right through it here coming up. So let's get ready. So I showed on my phone there the actual the kit I got from Kibble White's website, but here I'm actually going to just show the actual package it came in. It came in this HD Panhead 4865 lightweight racing spring kit with 6.600 max lift, and there was the same part number. What they mean by lightweight is, of course, you'll see that in the top retainers they got holes in it for lightweight. They reduced this a few ounce, maybe an ounce, by removing that extra material. That's the lightweight stuff. And then on their website, if you remember that picture I just showed you, that actually doesn't show lightweight stuff. It was just all, didn't have that in it. It was just, I didn't want any confusion there, is what I'm trying to get at. So now we got the numbers all figured out. We got the other head on a measuring thing over here, and we're going to talk about it. So let's go over there and talk about it.
I got this adjusted down past, like right at 700. So that's more than what we're going to need. What we have here is we have a 470 lift cam. We need 60 plus 60 thousandths over travel, which equals 530 thousandths. Plus we need, when we put the seal on, we need an additional 110 thousandths for the seal thickness after it's put on. So that's a reduced, basically, gap. So for a total, what we need without the seal, because see, the seal isn't on there yet.
Right.
So I need a minimum of 640 thousandths. Okay, so what we're going to do here is press down on this, and we're going to start counting this little dial is 100 thousandths. Each one of those that moves, it's going to start moving. So there's 100, 200, 300, 400, 500. Whoops, I lost my play. 500. Oops, I'm touching it. Dang it. 600. 640. 600. And I got 645. So 645 gives us 5 thousandths more than what we really need, which is perfect.
Yeah. The next thing we could do possibly is put the seals on, kind of mock it up, put it in the...
Before we put the springs on, we could do it again.
We end up sacrificing seals to
No,
do a...
right before we put the springs on.
Okay.
because you put the seals on first,
Yeah, that's true.
and then we could come back.
Oh
here and
yeah,
do
we
this.
wouldn't sacrifice them because we know what we needed, and then we got them turned down to that.
Right.
Now, if you didn't know what you needed, then yes, you would have to sacrifice.
We would have to
seals.
do this.
Yeah.
We would have to do this exercise, or you should do this exercise before you cut down the
Valve guide.
the valve guide. And the only reason that we're showing you this now, this is what we did with the first head. And we knew that I needed to cut this guide down to a specific dimension to get this free play.
Right.
We will also turn this head around, and you also got to, when you mock this up, you got to do it somehow to where the valve and the head and the valve is in the same plane. So what I did is I put this piece out here and got this leveled up. I put this on here and I leveled it up. So I can't get on the valve guide right now. The valve, it was leveled, perfectly leveled. And so I got everything level, so it's running straight up and down at straight. And so, you know, and I got just a real weak spring on here, so I can just press it down myself with a finger.
But you had hold tension on the keepers. So yeah, perfect. That's good. Yeah.
Yep. Put some on the seal.
Yeah. The retainer's in there already, so it's ready to go on.
Gotta push hard. There it is. Then we gotta put this down on that.
All right.
Remember a light?
Yeah, well, I gotta hold this like lightly so I can actually move a little bit.
Yeah, lightly. You gotta be able to be handy here somehow. You got it?
Yeah.
It looks like it's down all the way. Yep, it's down all the way.
Yeah, and then when you get it installed, make sure you're checking for it if make sure it's holding on there, because like we had one that didn't
We
want to.
had one that was loose after we got it on there.
Yeah, and then you can see that the lower retainer moves, so then there's brass from the guide. So
Now we're gonna put this back on lightly, and we're gonna go measure it.
okay,
Because if we don't have enough room now,
with the seal
if
installed,
our measurements were wrong, then we gotta take the seal off, ruin it, and we're gonna have to grind the guide down some more.
yeah, just because the front head was perfect and worked at that number doesn't mean this one will.
Okay, let go of the valve. Okay. Okay, so we need 530 minimum total because we got 470 plus 60. So
Yeah, like before, each one of them little marks in the little dial is
is 100. And every time that goes past the 0, it's 100. So we got to go pi there, 5 and minimum 30. 1, 2, 3, 4, 5, 10, 20, 30, 40, 50. 50 to touch. So we are 20 thousandths more. So we got 67, we got 60, 70, 80. We got 80 thousandths of free travel. We went a little further than we needed to. That's okay. That's definitely not going to hurt anything. We got plenty of room. These retainers, see that seal, the tip of the seal, that red part, sets up higher than our initial measurement of the 110 thousandths. I didn't take into account that once you pop the seal through it, that seal part tapers upward. And if you watch this when it goes down, you don't get to see this. This is a real weak spring. You don't get to see this.
with the real springs in it.
Yeah, let me turn this a little bit.
It just happens to be the right, kind of the right size. Anyway.
And then when this goes down, see, it comes down and touches that. But when we touch that, we're way. Now, if I just come down to touch it, we're still good. We're at
that's 40.
10, 20, 30, 40. Yeah. So we're 10 thousandths over. Actually, we're only about 10 thousandths over to just lightly touch. And so, and 530, here's 530. Go down to touch and come out here. 10, 20, 30. There's 30. We got some gap there. See, you can see valve there. We're not touching at 530. See, so we got extra room. So we're perfect. We're perfect there.
Yeah, then we can just go ahead and put the other seal in, put it all together, and get it ready for the next little test we're going to show.
Yeah, we can test the other side too. But I measured the same. It's the same amount.
Right. We ground them down the same amount, so it should be about the same.
The intake.
Yeah, intake now.
1, 2, 3, 4, 5. Wait a minute, it slipped on my finger. Okay. 1, 2, 3, 4, 5,
10,
20, 30, 45. Okay. We got plenty.
Yeah, and we want to make sure we check each one because we don't want to just assume. So that's why I wanted to show that. Okay, now we can put those springs on this side now like we did on the other side, and now we can just, this head will be buttoned up and ready to go.
Put this head on, and we don't have to worry about it.
Yep. Okay, we got the head installed here. For now, we're going to do the next test here. We're going to see our travel test. And
got solid lifter adapters, so we're not messing with hydraulics. This is just a kit that I bought years and years ago when I thought hydraulics were a problem. And so I bought these. Haven't used them since. But for this deal, this works great because this don't give it all. So I got 2 push rods here. But we're going to do 1 push rod at a time. And we are going to go over there and we're going to roll the motor over till both of these are all the way down. See, one's down and one's up right now. So we got to roll it over to compression. And when the piston's down on the compression stroke is when both valves are closed. And that's where I want to be so I can put the push rods in and set them up snug. And then we can roll it over to where one pushes all the way. It'll be 1 at a time. So, keep a long one.
Yeah, we got one short one and one long one.
That's a front one. Okay, so. Neither one of these want to fit it. take the nut off then, I guess. Once we get the hydraulics will give a little, and you can pop these in. These are hydraulic push rods.
Right. Yeah, it's hydraulic engine, so I mean, yeah.
These came with push rods, and I got the old push rods somewhere, but I'm not going to worry about tightening them.
Yeah, we're not doing nothing. We're not doing any load testing. We're just
No, they're not.
travel testing.
And then you roll it over to where you can just turn it. Okay.
Ready for that?
And I got a pencil mark right there.
So what's next?
I'm going to go get the other short one, and I'm going to put it in there.
Yeah. Now we did this already with the front head, but we had to take it back off, of course, because we had to put the rocker box cover on. You can't do it while it's in the motor, in the frame like this. So that's why we had a long one and a short one here, because the front one has there's a longer push rod than the rest, and that's the farthest reach exhaust front.
Okay. 12. Each flat is 5 thousandths on these push rods. So 12 flats is, or 2 turns, is 60 thousandths. So right now, we're going to go over, right now I got them to where they just turn, see?
Right.
So now we can turn the motor over one at a time. And then we can, check free play.
All right, we got the rear valve compressed, so it's opened up, and the rocker is all the way up on the from the push rod. And what we can kind of, it's hard to see it, but we can see valve stem in there. And now he's going to start turning the adjustment and see what we have remaining after we have it set.
That's 30 thousandths. There it is. There's 60 thousandths.
All right, so let's see if we can still see a gap here. You can see it's more compressed. And
See any shiny up in there?
I did with my eyes, but I'm trying to pick it up with the camera. It's down in there. I can see it right there, right above the, right down there, right between that second spring coil there.
Okay, we got plenty then.
Yeah, it's right there. It's hard to see it, but it's there.
And it should never get to there. And we're not touching the seal.
And your way.
And you can see the seal. It's not touching.
No, I can see the. I can see the red part of the seal.
Yeah, it's not pushing it. If you couldn't see the red seal, then it'd be touching it. So.
Yeah.
One round. That's 30 thousandths.
Okay. Now we see here. Yeah, we can see the valve. I can see the valve seal. Anyway.
You can see the top lip of it.
No, the way the spring's sitting, you can't see nothing.
All right. Well, it should be good.
Yeah. I mean, we could try that with the different springs, but
Yeah. Well, yeah, because see here, if you get way down here, I can see shiny valve above the seal.
oh yeah, there's the red part for the seal there, and right above it's the shiny part for the valve stem.
Yeah.
So
We got plenty of
yeah,
overtravel.
excuse me, we're good there.
We're still good, and we're already at 60. So we got.
And then the front head is just like this one. So I mean, and it measured out just like this. It's kind of comes the end here on this one. Otherwise, we get more involved, and it's gonna be a longer video when we go to put all the rest of this back together. We can do that all off camera. And next thing you know, the next video will come out. We'll have the heads all installed again, and ready to go, and we'll work on putting the
Hydraulics and the push rods and timing.
Yeah.
Excuse me.
Anyway, this is pretty much how you do this, I guess. So we struggled for a while, but we got it, and we feel a lot more better about what we got for the result here on this. So hope you really enjoyed this, and we had fun here, and we'll see you again soon.